Okay, so we will see now in the OpenGL atomic structure. So an atom has it has electron, and electron revolves around the nucleus, and nucleus primarily it consists of proton and neutron. So they are packed in nucleus, and they have some kind of positive charge, and electron consists negative charge, and it revolves around the nucleus. So that is the kind of grammar. So that is kind of the architecture of an atom. So can we kind of simulate okay the way atom works? So that is the concept. Okay, so we have atom, we have a nucleus occupied. We can see the nucleus occupied. Okay, finally we got it. Okay, so this is nucleus kind of, this is the nucleus. Okay, it has one is neutron, and one is kind of proton. So this is the nucleus. So we have nucleus.opt, and we have set specular as 0.4, shining as 20. Okay, and we have scaled it to 0.6, so it will be that big only. And here we have at the center we have one light source. Otherwise we have a ring. Okay, so we will scale it ring little bit. 1.25. Okay, so S 1.25. Okay, and we transformed 90 degree, and okay, so we can see first without transformation. That's it, and then we have 4 light sources and one at the center. 5 light sources we have made, and now we have just the solar system name is still sun and moon. So we can kind of okay, so probably I can just amend the axis, and okay, so probably I can comment it. So we don't want any electron now. Okay, and everything is commented. So we'll see how it looks. Okay, so 4 light sources we have placed, 2 in Z direction and 2 in X direction, and we have set a specular and shininess. So what is the status? So it is 6. Okay, so this is how it is. Now we are displaying x, y and z coordinate. So red being x and green being y and blue being z. Okay. So this is how it is. So proton and neutron, and then we have one circle around it. Okay, we can rotate nucleus also, but anyway, I believe it will not be the actual case. Okay, so this is how it is. Now we will add electron to it. Okay, now first we will kind of transform the circle around it. So we may place a kind of letter will place, not required right now. And now we'll do fixed transformation. So 90 degree on y-axis. So y-axis, when we see the graph, then it is in xy plane, whatever we see. Okay. And then now we'll rotate along y-axis and then followed by along z-axis, and we'll make it a little bigger. So we'll see the effect. Okay, it is bigger. Can we see it is rotated now? Okay, so the circle is not on any of the axes. Probably we can rotate other things. Okay. So it is not lying on any of the axes. It is clear now. I think it is more clear now. It is along y-axis. Okay, and from red it is 30 degree. So this is what it is done. Okay, I mean we can tilt the y degree. It's not that we cannot do. Or so this is how it is. Now we have electron path, and that is kind of 30 degree from the x-axis. Okay, now we can add the electron. So it is still in the name of move. And so what we are doing is local axis we are transforming it by through the y. Okay, so we wrongly said 90 degree it is along x-axis and then along minus z-axis 30 degree. Now along y degree 30 degree we are transforming, and then we give a fixed transformation of 4, so probably we will make it 5, and size we scale it by 2. So there are 5 light sources as stated. So now we have only one light source, that is at center. Okay, so we can enable it, there is no harm in it. So one light source is in minus z. Okay, I believe this is ring. So ring will enable it. Okay, yeah. So light sources are enabled. One is in z minus z, x and minus x. Now we have enabled and we can add this electron to it. So electron is kind of 30 degree along x-axis that we have rotated. So we can try. Okay, we really have an electron. Okay, and it is receiving light from all directions. From center it is receiving maximum light. Okay, so what is the status? So we have 7 shapes. So this is Mr. Electron, red color. And can you see the lighting model? it is receiving maximum light from the center, and all around also it is receiving light. But we can see that it is glowing more towards the center. Probably we can see increase the size little bit of the electron. So we can make it scalable as 3. This would be just it. Okay, so 7, and then on local axis we are rotating, and this is the electron is saying maximum light from the center. Okay, we'll see the axis of the electron. Okay, so moon children axis. Okay, so now we can see the local axis of the electron. It is visible now, clear cut. Okay, so electron has its own local axis, and that is blue, red, and green. Okay. It is more clear now. So electron has its own local axis. So one is the full local axis, full global axis, and one is local axis of the electron. So electron is kind of little bit tilted. We can see that Y is kind of, I think it is parallel, but whereas blue and red are not parallel. So it is 30 degree. We have rotated along the Y. So, and then X and Z are tilted. Now we will rotate along the Z axis. Okay, so where are you, Mr. Electron? It is 6th one. Okay, it is rotating. Okay, so we can rotate kind of anything along any arbitrary axis. Can you see this? Okay, what the electron is doing is it has its local coordinate, and in the local coordinate, first it shifts 30 degree, and then along Y axis rotation, and then along Z axis. Okay, then it is translating itself, and then along Z axis it is rotating. So electron is rotating around nucleus. Okay, I mean, wonderful. So now we can add more electrons. So I'll add rings so that we can see the electron. So I'll add one more. Now I have a ring, and that is 60 degree along X axis, first 90 degree. Okay, and then 60 degree along minus Z axis. Okay, or probably we can make little leave. Okay, and then another one, we are adding the moon, and we are not adding any axis now, and we are transforming 60 degree, and here we can make it 5, here also, so we can make it 1.25, 1.25. It is, means whatever we are using the software behind the scene, we are not changing anything. So we have kind of a full-fledged software in drawing the kind of OpenGL. So it's only one class, that is shader. That's it, and it's a very small file. Okay, there is nothing. only required is we have to place the transformation, that's it. So like this there can be hundreds of files separately for separate diagrams. And now we are scaling, so as per fundamental we will scale 0.3. Okay, coloring same, we are giving it red, or maybe to differentiate we can make it yellow, but I don't think in reality that would be this. Okay, so we have 8 now. Now can we see there is a yellow color electron. We have not drawn the local axis for the yellow. Okay, what is the count for the yellow? It is 7th one. So 7. Now yellow would rotate on its own axis. Okay, whereas red would rotate on its own axis. Okay, if it is not very clear, then we can bring it complete down. Okay, and the good thing about this is we can rotate. Okay, so okay, this is kind of anyone would be looking for this diagram. Okay, probably I can just, if it is possible, then this is Linux Mint. Okay, so auto hide the panel, so we can make it auto hide, so we can see it better. Okay, so this is the scenario. Now we can make anywhere they are rotating on its own axis. This is it is receiving light from the center, and all other 4 lights it is also receiving. Okay, so same way we can make the red electron move in its own axis. Okay, so pretty well, this is what I feel. Okay, so we will add few more. I believe that it is big. So idea is that we can make it smaller, and so we will kind of first we'll make the ring smaller, so we don't need scaling in the ring. So it is easy now. So and here in the moon also we will make it 4 only, because it is crossing the kind of boundary. And here we will make it 4. So 4, and that quite 3 will just leave it as it is. Okay, now we'll add 2 more, so we'll finalize it, and 2 moon we'll add. 2 electron we'll add. Okay, size will change to 3. Okay, so we will try. Okay, so it is smaller now and it is visible. So how many are there? Are 10. Okay, so this is how it is. So electrons we can see, and one electron is in yellow in color, and we can choose any electron and we can just rotate it along its own axis. Okay, so at runtime we can remove everything. So with this software, everything is possible. Okay, so this is something historic diagram of electrons, where we can see that all are rotating in its own axis. Two are rotating in same axis. Okay, so okay, so two are not supposed to rotate on the same axis. What mistake we have done? Okay, there should be 4 rings. One at 30 degree, one at 60, one at minus 30, and one at 50, 150. Okay, so 150 and minus 30 are coinciding. This is what we can see. So what we'll do is we'll make it as 120. Okay, so they should not coincide. 30, or we'll make it in 90, 120. Okay, so that should be okay. And in the moon we'll make like 30, 60, 90 and 120. So they should not collide. Okay, so there are 4. Okay, so this is what we want, probably. Okay, so all 4 are on different axes that we can see. Now we'll try. Okay. Okay, I believe we can add, so it is up to 120 and 150, 180, we can add one more. I think that should be enough. Okay, and then we'll bind up. So we'll add 150 is coinciding with 30. This is what we are seeing. So 180 should not coincide with anyone. and we have one more electron, and it is 180. Okay, so this is kind of this is really a kind of a nucleus, and then around the nucleus we have electrons. So we can remove kind of whatever we don't want. Okay, so in the 6 we have one axis, so that we can remove 0. And in the 0, we can remove. Okay, one axis is at okay, so that is not a child of one nucleus and then ring. Okay, so that is global. Okay, so we'll remove Mr. Global. So it went away. Okay, like that we can remove all the rings if we want. So in this software everything is available. Means it's like very small software, and okay, now this is the natural. Okay, so this is natural. This is how actually it rotates without any lining. This is actual electron movement. Okay. This is how the electrons are. Okay, so we can let anyone move. No? Okay, so this is how the kind of electronic structure. This is